Hello. Okay, so, well, I'm Carlo Brunetta, and, well, I used to be in academia. Now I'm more of a researcher as a consultant. And I'm here to present to you this particular work that we are currently bringing up to public, which is about computable contracts on blockchain. So it's not only me, it's several people. It's a way bigger project, and this is like a really specific piece into this project that we are currently presenting and bringing in the public domain. So the real title is way longer, as you can see, and it's made with different components. Where I want to focus on the different aspects that builds up to this idea of computable contracts. So there's this verifiable computation outsourcing, which is coming from cryptography, and that's what I will show you what it is as a problem. And then, of course, it interacts with blockchain transactions. Then, of course, some of you will say, well, what about smart contracts? What are the differences with respect to these computable contracts? And that's something that I will bring at the end when you know all the different pieces of this work. So verifiable computation outsourcing, it's a really old and well-known problem in cryptography. And the problem it's made with different actors. Where a user has some data, some information that wants to evaluate some function on it, being an algorithm, a program, or anything. Doesn't have the computational power, so it asks someone else, which we call evaluator, that will compute this evaluation. Now, since we don't trust the evaluator to do his job properly or honestly, we demand the problem to provide something else, which it's basically a proof that the computation effectively it's made correctly. And this it's effectively can be verified by a verification algorithm or protocol. So this is the high-level representation of the problem. And in cryptography, there are a lot of different frameworks, tools, schemes, and primitives that allow us to do this thing. The only point is that each one of these tools effectively solves a specific flavor. Well, I like to call them flavors, because the verification might be public, the verification protocol might be interactive or secret. So you might require a secret key to verify the computation. The function might be confidential. So there might be other peculiar properties that are required in all this simple diagram, and they highly depends on the application. So solving this problem highly depends on the property you want to achieve for the real application. So that's why we took a step back and tried to see at the whole problem in a more abstract way. Because there are clear actors, so you have users, evaluator, and let's say a verifier, which might be external, that has to properly interact both cryptographically, both data handling, but since, well, we are in the real world, there's even rewards and money that you want to pay someone to do this service. So all these different aspects, technical, economical, and other type, will be collected into what we think is a contract, because it's an agreement between all these different actors, how to do, and even how to reward for the services. So that's what I consider is a contract. And let me show you how we move from this type of contract, which is more an abstract idea that can work everywhere, to something more concrete on the blockchain. Sorry. So To bring up the actors, well, we have the users, the evaluator, and the verifier, as we will have in a normal scenario. But now we have to add all the blockchain-related actors, where in this case it's miners. But you can see them as validator. Doesn't care which consensus they use. The point is that the miners are the ones that handle these transactions. They maintain the network, and they create a sort of data access control. The reason why I say data access is because all the interaction between the different actors goes through transactions. So you exchange transaction with the network to provide data or to retrieve data. And then the miners, by using threshold cryptography, will be able to create some sort of data access control so that only specific user can retrieve data or can do some specific action. And that's why all these different actors, each one has its own responsibility. Miners creates the infrastructure, evaluator computes, provides computational power and service, while verifier will do the checking that things are computed correctly, which is yet another different computation at the end of the day. So how does this computable contract effectively work is that, as I said, transaction becomes the mean for these actors to interact. So in this case, the point is that we have a user that will send a transaction through the miners to basically upload their data in a confidential way. The data is encrypted, of course, but it's there in some data availability layer so that later on the evaluator can interact with the network to retrieve this data. And then in the same way, it can put back the outputs in the network on the DA layer, and then through the verifier will be able to retrieve this data, verify that it's indeed correct, provide assurance, let's say flag or something to the network, so that whenever the final recipient wants the data, it can only be provided because the verifier said, yes, it's the correct data, everything is correctly executed, everything is paid correctly, so the data is there. You can get the output. As I said, this is like a big machinery of many different transactions, which kind of works in a sequential way. You have to follow a specific path from the beginning till the end. And that's kind of the point of how we develop these computable contracts. Because these contracts are encoded in a specific way that the blockchain, and ad hoc blockchain, but they are designed to be a transaction with all this different information. And there are mainly 4 different parts. One, it's all about the information about the contract, what you want to do, to whom, how to pay, which cipher suite to use. Then the second part, it's all about the evaluation. So what to compute, what to verify, and so on, which will be the cont3. But then there's all the information about who can retrieve the data and when, or other type of conditions that one can have on retrieval. And then these 4th parts, that it's basically a wrapper that describes how the contract must be executed. So it basically lists how this different transaction has to be executed and how and when one is able to move to the next step in the contract. So that, let's say in this example, you cannot execute the transaction B in the blue square before you have done all the previous steps. So you want to know that which transaction must be made and in which order, so that you follow a really strict but agreed upon execution. So I was really fast, but that's basically what these computable contracts are all about. It's about describing how all these different steps must be made and how effectively they are executed. That, of course, becomes a peculiar question of how much, where's the difference with smart contracts? Because at the end of the day, smart contract allows to execute outsourced computation. They are transaction driven because to interact, you must provide a transaction in a sense. And they work as a state-based execution. So you go from one state to another. Well, there are differences, which are more on the how these different ideas effectively comes to play in the application. Because smart contract has codes on-chain and it's executed on-chain. So if you want to run AI training, that's expensive computationally, and on a smart contract will be made on the chain, which will be too expensive. While our computable contract, it becomes some sort of pointer list. So you know where to point, you know where to retrieve data, how to securely, and then you just follow precisely what you're supposed to do. Which becomes the second type of difference with respect to smart contract. Computable contracts are predefined. When you decide how you want to compute something, that's in the contract, and that's how it's executed. Well, smart contract will allow non-deterministic behavior because the code will allow to get different type of execution depending on the transaction once provided. So there are differences between the two. These are the easier one to explain without entering too much into details. But that's why we are bringing it as a different way of doing outsourced computation in the context of blockchain. I definitely been too fast. Well, you can find the e-print online. I think it's since Friday, it's out. I'm open to questions and something, well, of course. I mean, didn't want to take too much time since there's a panel effectively later on. Thank you.
I was just thinking, what are the use cases, problems you're solving at the real world use cases and things like that?
Yeah.
I definitely don't understand all of that, but I mean, I like the graphics and how you graph that for one around all of it. So like that.
Yeah, well, we can? Okay. Yeah, because so there's a project. So this is part of our papers that we are bringing up of different research based. Because the application, it's related to AI marketplace as one specific type of application. Because you can see that here the point is you provide the data and you have a data access control to retrieve, but it's both related to cryptography and privacy and confidentiality, but even on an economical arguments. So the point here is that and the computation, it's basically off-chain. So it's basically creating this environment where you can share data with some entity according to your own willingness. So selling data in the AI model context, and the other person can effectively do the execution, inference, and so on offline, while still keeping verifiability. So this will allow to create
offline, like, intermediary for, payments and things like that, like to be able to negotiate and send and receive and, your behalf.
Yeah, well, the project has many different applications. I mean, I'm coming more from the technical side, and there's agent-oriented application. The one I'm more familiar as, because I understand better the environment, it's really the marketplace. So people bring in their data, having people that wants data, and you have a whole economical exchange where you might connect different actors. So you bring the data, someone provides the model, someone provides the computation, while a fourth party will get the final model. So that's why like this contract can be really complicated. But
we all completely independent parts.
yeah. The user in this scenario and the evaluator and the verifier, they are different. They can be potentially different actors. And then this becomes like a layer where they can get the agreement on and execute this type of peculiar financial computational type of contracts. Because you have a financial side, well, the economical side of paying for a service, checking that the service is correctly executed, while still maintaining security according to how the actors want to agree on. Because it depends, like you want security in a sense, maybe you want data to be secure, but not the model. So that's why like it's the protocol, it's really adaptable to a lot of applications.